Hi class. We are now going to start the part 2 of 16.4. So we're just going to do the rest of these proofs. The next problem is given x is the midpoint of WY and VZ, prove that the two corresponding angles are congruent. So with this, we know that first of all, we're going to mark up and analyze to figure out which of the theorems we can prove the two triangles are congruent with, and then we're going to use CPCTC to prove the two corresponding angles are congruent. All right, so x is the midpoint of WY. So I like to mark WY right here. X is right in the middle. That's the midpoint. If x is the midpoint, then we know for sure that those two sides are congruent because x will be right in the middle of them. It's also the midpoint of VZ. So x is, again, the midpoint of VZ. So that means VX and XZ are congruent sides. All right, now we need a third item. We have two sides. We don't have another one, but because these are two crossing lines, we know that the vertical angles that are formed will be congruent also. So that's something that we're not given, but that we know, or we're expected to already know. And with that, we have a side, as we go around, we have a side, angle, side relationship to where these are congruent by side, angle, side. All right, so we can prove they're congruent by side, angle, side by stating each of the three items are congruent to each other. And then once we've done that, the angles that are corresponding will be congruent. So which angles are they? Let's see, x, w, v. So x to w to v, it's this angle that we're trying to prove congruent to x, y, z. X, y, z, this one right here. All right, so those are our two corresponding parts that we're trying to prove congruent to each other. And we'll do that through CPCTC after we've proven the two triangles are congruent. So what are we given? That x is the midpoint of WY and VZ, and that's given. Now, what did we get from that information? We got that the yellow sides and the green sides are congruent to each other. So those are going to be our side and our side. So we'll say WX is congruent to, now we had WX in that order, so we need to do YX in that order. It's congruent to YX. All right, and that's by definition of midpoint. And then so also our, let's see, VX, our two green sides, VX and ZX, are congruent also by definition of midpoint. All right. Now, we have our side and our side. What we need is this included angle. The included angle, because it's the angle between the two sides, and those are angles congruent by vertical, by the fact that they are vertical angles. So let's go 2, 1, none. So WXV, angle WXV is congruent to, we have to do 2, 1, none again. So YXZ, angle YXZ. Right? And that's because they are vertical angles. And then with that, we have side angle side, the included angle between two sides. And therefore, triangle XWV is congruent to triangle XYZ. And again, I just used the statement above. That's very handy. But put a triangle in front of it so that I know that we're talking about the triangles being congruent, and that is by side, angle, side, because as we move around at side, angle, side, therefore our angles, XWV, will be congruent to our angle, XYZ, by CPCTC. All right, good, everyone great? Now, we're going to do number 4. Number 4, again, analyze and mark to start. So we're going to start by analyzing. We have JM is bisecting KJL. So this angle is KJL. So if JM, and I like to mark these, remember, as a bisector, then that means the two angles on either side of the bisector are congruent. We went over that in class several times. And if those angles are congruent, which is kind of cool, we have one set of congruent angles. And then it also tells us that JMK, so from J to M to K, this angle is congruent to JML. So JML is this angle. All right, so we have two sets of angles. We need something else. Do we know something that's not given? Yes, we do. And that is that JM is a reflexive side. and therefore JM will be congruent to JM itself by the reflexive property. All right, so we're given, I'm going to start with JMK is congruent to angle JML is given, and that just gives us a side right off the bat. Then we'll work with this next part. JM bisects angle KJL, and that's given. Now, that's not an actual side or an angle that's congruent. It just is information that's given. But from it, we know that KJM, that angle right here, angle KJM is congruent to, we started at K, the none, then JM. So we're going to start at the none, no arcs, so LJM. LJM, and that's by definition of bisector, or bisects. That's what it gives us. Alrighty, so we have two angles are congruent. We gotta actually put side there. I must be pretty tired. I'm at angle. So we have two sets of angles congruent. Now we're going to do the side, and the side is a reflexive side. So JM, now I'm going to look right here. JM and JM are in the same order for the angle statement, so we're going to use that in that same order. JM is congruent to JM by the reflexive property of congruence. All right, and then next, number 5. Let's see, we have an angle, side angle. So an angle with an included side and an angle, the side that's between the two angles. So that's why we know triangle JMK is congruent to triangle JML by angle, side angle. And therefore we can state that JK, just right here, is congruent to JL because they're corresponding parts of two congruent triangles. Therefore, they're congruent. So JK is congruent to JL by CPCTC. All right, and we've got that one. All right, last but not least, we have number 5. So it says BC is parallel to EF. All right, now BC is parallel to EF. Gives us a variety of information. We don't know those two sides are congruent, but we know they're parallel. That means if this is a transversal, alternate interior angles will be congruent. That's one thing. And then if this is a transversal, these alternate interior angles will be congruent. We know that for sure. Okay. Now we also know that D is the midpoint of BF. So if this is BF, D is in the midpoint, then those two sides are congruent. So we can use that information and do angle, angle, side, and that will work. By the way, if you want to, you can state these two are congruent because they're vertical, and you can do angle, side, angle. But I'm just going to use what I have, and it'll be great. All right, first thing we're note that BC is parallel to EF, and that's given. And from that information, we know that angle B is congruent to angle F because they are alternate interior angles. And we also know that C and E are congruent, angle C and E. So angle C is congruent to angle E also because they are alternate interior angles. All right, so we have two angles congruent. All right, now we need these sides, but we first need to state our given that D is the midpoint of BF. And we have to state that as given first because it is that information that allows us to note that BD is congruent to FD. So with D being the midpoint, then we know BD, segment BD is congruent to, now notice I went from the side of one angle in to D, and now I'm going to, with one arc, Now on the other one, I'm going to go from the one arc to D, so I need to state it in that order, BD to FD. I don't have anything to go by but other than the angles that are congruent, so I have to go from 1 to none, B to D, and 1 to none, F to D, to state them. All right, and those are congruent by definition of midpoint. So it states in the given that D is the midpoint. All right. It's done with that. And then number 6, because that's a side, and it happens to be not an included side, as you go around, we encounter an angle, and a side. So it's angle, angle, side. Sides outside of the angles, not in between them. We can state that triangle. Ooh, we don't have anything to go by, so we're going to have to come up with it. How about none, 0, 1, 2 arcs? So 0 arcs, 1 arc, 2 arcs. So DBC is congruent to triangle, so we need to go from 0 to 1 to 2. So DFE in arcs. All right, so those are my congruent triangles, and that's by angle, angle, side. And because the two triangles are congruent, then for sure the corresponding parts are. So ED, which is right here, is congruent to CD. They're corresponding parts of two triangles that we just proved to be congruent. So they will be congruent by CPCTC. So you just have to write that in. ED is congruent to CD by CPCTC. All right, now as you're going through your packet, you're going to notice that you have a bunch of proofs to do. If you want, we do have proof. We have labels printed out and on the table of in the front of the school. So if you want to grab those and use those quickly, then that might be really good. And you can just stick the labels in. Or you can look at them that are following the packet, and you can just cross them off as you use them and write them in. Okay. All right, finish up the packet. As you know, that's the very last lesson, as exciting as that is. So we'll be reviewing and testing over the next couple of days. So good luck.